Good morning, guys. Today we're going to talk about finding the area of a regular polygon. And one of the things I wanted to do before we started on the lesson itself is show you something that Russell and I have been working on. And I'm hoping to take our lessons towards actually relating to this in a little bit. This is the tractor that I brought home during Christmas vacation. And I told you guys about this in class. Well, Russell and I started taking it apart. We're getting ready to rebuild the motor on it. And one of the things that when we talk about motors, often we'll talk about how many cubic inches the motor is or how many liters. That actually relates to this. So Alex, if you'll come over here. When we talk about how many cubic inches a motor is, we're actually talking about how much volume each of the cylinders, which are these areas right here, has. And what they're actually doing is they are measuring to see how much volume each of these cylinders has. That's usually measured in cubic inches or in liters. The older motors that we have in our cars, those were measured in cubic inches. The newer motors that we have are measured in liters because, as we know, the world is going more towards a metric unit of measure. Okay, so Alex is going to bring this over, and we are going to talk today about finding the area of a regular polygon. Again, this will lead eventually to us being able to find the volume of a cylinder. Okay, so today what I'm going to demonstrate is the area of a pentagon. But this will work for any regular polygon that we do. So I'm going to grab a pencil. That one's not sharp. Okay, penguins will do. All right. So we've got our pentagon down here. And to find the area, we are going to use the formula area. Oh, and that pencil's not sharp. Let's see. Try this one. Area equals 1/2 the apothem times the perimeter. Okay. Now, this pentagon that we have has 5 sides, and each side is going to be 6 units long. Okay? It's a regular pentagon. That means all of the sides are congruent, all of the angles are congruent. So, if that is the case, then it's really easy for us to find the perimeter because all 6 sides are the same. So the perimeter is equal to 6 times the number of sides, 5, which gives us a total of 30. And let's use inches for a unit of measurement, so 30 inches. Okay, now that gives us one of our variables, but we don't have the other one. We don't have the apothem. Now, to find the apothem, we need to know what the center of the polygon down to the side is. That's what the apothem actually is. And we actually spell that word A-P-O-T-H-E-M. Okay, so this takes a little work. Again, the apothem is from the center of the polygon down to the side. It bisects the side, and it's perpendicular to it. So I know that if the entire side of the pentagon is 6, half of that side is 3 inches. And looking at this, well, it's kind of hard to to figure out what that would be unless we start thinking along the lines of, well, we could use our triangles. Okay, so I am going to draw the other segment that has to do with area of regular polygons, the radius. Okay, this is our radius. Okay, now I have a right triangle, and I can use right triangle rules, like the Pythagorean theorem and the trig functions, sine, cosine, and tangent. So, I only have one side that I know the length of. The radius, the apothem for that triangle, I don't know them. Okay? So, I need some information that I can use to solve that. To do a trig function, I need to know at least two values, either an angle and a side, or I need to know two sides. So let's go to finding the measure of the angle. Now, we know that we have a pentagon, right? And so the sum of interior angles of a regular polygon, sum of interior angles, is equal to n minus 2 times 180. We studied that in our quadrilaterals chapter at the very beginning when we found the area, or the measure of the angles in a polygon. In this case, since it's a pentagon, n is going to be 5. So 5 minus 2 times 180. 5 minus 2 is 3. And I might want to get out my calculator to multiply that, but 3 times 180 is 540 degrees. Okay, now, if the measure of the sum of the interior angles is 540, each angle will equal 540 divided by 5, which is equal to 108 degrees. So each of the interior angles of our pentagon is 108. Now, our radius divided that 108 degree angle in half. So 108 divided by 2 is equal to 54 degrees. So this angle is 54 degrees. This angle is 54 degrees. Okay? Now, in looking at our triangle, I know that I need to find the apothem. I know the length of half of a side. So I am going to use a trig function to find the apothem. Now, thinking back to our phrase SOHCAHTOA, S-O-H-C-A-H-T-O-A. With the 54 degree angle, I know the opposite is A, the adjacent is 3. So A is my opposite, 3 is my adjacent. So if that's my adjacent angle and this is my opposite, I know the adjacent, I don't know the opposite, I know the angle. I'm going to use tangent. And the tangent of the angle, 54 degrees, is equal to opposite A over adjacent 3. And again, A is standing for apothem. All right, now, since the 3 is on the bottom, I can multiply both sides by 3 because this was division. multiplication undoes division. So 3 times the tangent of 54 equals A. If that's the case, then A will be equal to, actually, let's put the A over on this side. Sorry, that eraser's not very good. A equals 3 times the tangent of 54. Let's make sure our mode is in degrees. So 3 times the tangent of 54. That gives us an apothem length of 4.1291. 4.1291. So now we have our apothem length. And that's in inches. All right, now, to get the area, again, we said that was 1/2 the length of the apothem, which is our 4.1291, times the perimeter, which we said our perimeter was 30. Okay, so 1/2 or 0.5 times, and to keep it accurate, I'm just going to go up and grab the 4.1291, 45761. I'm going to grab that out of the calculator rather than just rounding off. This will keep our answer more accurate. Times 30 for our perimeter. And there's our area. Area is 61.9372 inches. If I was going to buy material to cut this out, I would actually need about 62 square inches of area. And that brings about something. We measured in inches, but area we know is measured in square inches. So I should have put inches squared, because we know that our area should be measured in square inches, just like it is for a triangle, a rectangle, a parallelogram, anything else. Okay? So that is our lesson for today. Now, one other thing that I will point out is that this pentagon has 5 radii. We only drew one of them. It also has 5 apothems. We only need one of the radii and one of the apothems to find the area, because what we're doing is we're using the perimeter instead to find the area. But this is actually based off of the area of a triangle. Area equals 1/2 the base of the triangle times the height. The height is taking the place of the apothem. The base is the perimeter. But then to find the total area, we'd multiply it by the number of sides. So perimeter is actually base times the number of sides. Okay? This last little piece of information, probably not quite as important. It just kind of helps you realize where the formula comes from. So I hope everyone has a great day. Take some notes on this. Maybe watch this a second time. Take notes. And then tomorrow I'm going to have you guys try a couple of problems that are the same type. Okay? Hope you have a wonderful day. Get out into your yard or somewhere where you're safe, but enjoy some of this nice weather. I've been actually spending a little bit of time on schoolwork from working outside. And it makes me feel a little better. So I miss you guys. I hope I get to see you soon.